Okay, welcome back. And now let's get into facial fat. So first, a general introduction to fat. And let me just quickly draw a little face for us, a little skull. We're going to look at something like this. And the idea of facial fat and the stuff that we're going to talk about is that there's kind of two flavors that we're going to see. We're going to see subcutaneous fat, and we're going to see deeper, kind of more structural fat pads. Okay, so the secret with subcutaneous fat is that this is the stuff that lives just under the skin, right? So kind of everywhere in your body there's kind of a superficial fascia that kind of contains a layer of subcutaneous fat. And obviously, as you gain weight, adipose tissue, subcutaneous fat collects more in certain places than others. And that's true of the face as well, right? And we will see all these places where it kind of collects. And not only collects well, let's just say it like this, it doesn't collect uniformly, right? And what ends up happening is, if I kind of zoom in onto a section, the fat lives in a layer, but within that layer there are little separated packets, kind of little septi that run in between these little compartments. And there's been a lot of research in plastic surgery in the last 10 or 15 years really looking at how these packets of fat, kind of these different compartments, form in this superficial layer, right? Because obviously it has kind of clinical implications if you're operating on somebody's face and trying to remove fat in one area or put it back into an area, right? So we will look at some of the stuff we'll talk about is subcutaneous fat, and they actually breaks up into nice little structural pieces in certain instances. So we'll talk about those. The other kind of fat that we're going to talk about is deeper kind of structural fat pads. And these are typically further down right against the skull, and they're either for kind of sliding resistance for muscles, kind of a sliding plane to reduce sliding resistance, or they're kind of a structural thing to hold muscles out. We'll see a couple examples in the face where this is really kind of important. We've already alluded to like orbital fat and things like that, but we'll see more of that. Okay, so kind of the critical fat pads, and I'm just going to do a quick schematic and then we're going to go into details. Okay, so the critical fat pads are orbital fat. I think you can guess where this is going to be. Right, we're going to have orbital fat kind of as the kind of primary packaging material inside the orbit. Okay, then as soon as we put our eyes and our eyelids on, we're going to have something called pretarsal fat. You can almost guess where that is, right? We know the tarsal plates are over the eyelids, and pretarsal fat is going to be configured actually only over top of the lower eyelid. We have something called malar fat, and the malar fat is going to occupy this nice little fossa, this nice depression that we've been looking at the front of the sunglasses. And this is going to be the primary, like one of the big ingredients to aging the face, right? A young face, you know, and kind of intuitively, you don't see any of this craggy surfaces on a young face, and that's because of malar fat, right? Malar fat is kind of the key to middle face appearance, mid-face appearance. Okay, next is something called buccal fat, and buccal fat lives in this pocket right here behind the masseter, right? So we have teeth, right? We have our cheek on the inside, and there's a muscle in there called the buccinator, which pulls our mouth side to side. When you're pushing food against your teeth, buccinator is what's doing that. We'll talk about that more when we get to expressions. But suffice it to say, buccinator runs right along the teeth on the inside, but there's still left behind the ramus here a little pocket where we're going to put this deep kind of structural fat pad called the buccal fat pad. Okay. Then the laundry this is going to quickly become a decent laundry list for fat. Okay, so next one we're going to talk about subabicularis oculi fat, which is typically known as SUF fat. And remember, we talked about abicularis oculi up here. Well, there's going to be a little layer of fat sitting underneath abicularis oculi on the inferior margin of the orbit. And this is going to have a lot of implications on, again, orbital appearance as people age. Okay, and then if there's SUF, there may be roof as well. The roof fat is a similar configuration, but this kind of occupies the superior margin of the orbit, and we'll look at that in more details as well. And submental fat, if anybody's out there thinking kind of where is submental fat going to go? Well, submental fat is a little kind of fatty deposit that happens underneath the chin, right? And then finally we have something called jowling and jowls, and this is kind of independent of all of these other pieces, and it comes in, there's a few different configurations of it, and again, this is like kind of contemporary research in plastic surgery. These guys are in there injecting dye into different sections of cadavers to see where the limits of these compartments of subcutaneous fat are. And there's been a lot of that to do with jowl fat, because they try to rejuvenate faces by operating on these things. And so it has quite a few clinical applications, but artistically it's great for us to categorize these things into very specific locations where there's actually ligaments suspending them. You know, this is the kind of stuff you need to know so that you don't have to observe it every single time. You can quickly locate the stuff just on constructional principles. So jowl fat is going to be kind of down here, and there's going to be a few different configurations. I'm not going to make this schematically accurate, but this will give you an idea where we're looking for that. Okay, so that's our little laundry list, and we're going to go through these kind of section by section. So let's start with orbital fat. Okay, so orbital fat, the bags that you have even when you're not traveling, this is what you have when you have bags under your eyes. And let's talk about the nature of that, right? Because it's really important for us to kind of put these in the right place. We've talked about the orbit as kind of a nice structure, and we've kind of, you know, the shape of it. We've been looking at this when we draw the skull. Well, it's great for, we also have the eyes kind of placed in, the lids, the tarsal plates. And now we have these areas, these interstitial areas that we know there's fat, but we need to look at how it configures itself, because that shows up on the surface, right? All the stuff in the eyes is really thin. Skin, you know, tarsal plates, they're going to show stuff through down here. Okay, so in this cross section that you see here, you can see orbital fat, which is F. And this is just like we know it. This is as we've described it. We've kind of seen it a little bit last week as well. D, orient you, the tarsal plate, the lower tarsal plate. C is abicularis oculi muscle, right? So this is that big kind of raccoon muscle. Nose is over here. Let me just kind of orient you. The big raccoon muscle that spirals around, okay, kind of anchors on the medial canthal tendon. It goes out like that, right? So that, again, to remind you and refresh, is the abicularis oculi. Okay, now the critical thing for bags under the eye happens to be this tiny little structure for E, which is the orbital septum. That's like this plastic wrap that's holding all the fat back in the orbit. It's kind of the retaining band, you know, and it's periorbital, which means it goes all the way around the orbit and just kind of suctions all that stuff in. But as you age, this structure loses its resilience, right? And gravity also takes a toll. And so what happens is, as you can imagine, it gets a little bit more lax. And when it gets lax, something like this can happen. Instead of being straight and flat, it gets a little bit bowed outwards, a little bit herniated, and all this fat. And I'll just try to do a nice quick fill as fast as I can. All of this kind of bulges out, and you can imagine the effect eventually onto the surface, and that's bulging fat pushing out the surface, right? That's kind of how all of this works. Okay, and so if we take away that orbital septum, in fact, the little fat doesn't bulge out uniformly. And if you've done much observation of eyes, and like one of my favorite things is to go on it's my least favorite thing is to be on the tube at rush hour, the subway. But if I am, I observe, right? And I always noticed bags under the eyes and little divisions between them, right? But I didn't know how to explain it, right? I couldn't tell you that there were in fact distinct bags, distinct fat pads of the orbital fat, but I had viewed it, I had witnessed it in real life. And in fact, it's the case, right, that you have, at least on the bottom, 3 distinct sections, right? So you have a medial section, which is called the nasal fat pad, or variously medial fat pad. And this kind of fills all the way up to the canthal, the medial canthal tendon. You have a central kind of fat pad, and then you have also a lateral fat pad kind of out by the temporal side, right? So nasal side, temporal side, nasal side. Okay, so that's cool. I've actually seen that in life, and I could always notice this one, and then this one sometimes appears unified, or vice versa. Sometimes these appear in different configurations. And sometimes it all bulges out in one uniform mass, but often you'll see distinction between those. Now, interestingly, as we kind of look above, kind of the superior part of the orbit, is that we have also nasal fat pad up here, right? And in fact, these seem to be the same fat pad snaking around on the nasal side, lashed over by the medial canthal tendon, right? And so you can imagine if somebody's eyes are bulging out, if their orbital fat is bulging out, this could end up looking like a little bit of a balloon animal with a little kind of tie down right across it, right? Puffing up here, and then lashed down right there. Okay. Other thing, just to clarify, there's not really a lateral fat pad. There's not the equivalent on the top from up here. There's a tiny bit of lacrimal gland, your tear duct, but this is kind of up underneath the orbital margin, so we don't really see that too much. But you also have something called pre-aponeurotic fat pad, and this is kind of like the central fat pad down here, but it's up here. And really this sits over, it's called pre-aponeurotic because it sits over top of the levator muscle. Remember, we have that levator muscle that came down, attached, flared out, grabbed onto the superior tarsal plate. It flares out and attaches to that with an aponeurosis, a big flat tendinous sheet, right? So that's going underneath this little fat pad back into the orbit. And so this kind of hangs out on the top. Okay, so that's the configuration. Let's look at these in dissection. And this is going to be a little bit gross, so avert your eyes for the next 4 or 5 minutes while maybe 1 or 2, depending on how long I take to describe this. But this is what it looks like when you kind of reflect the orbicularis oculi, right? So that's what this big muscly mass is. And here it is, like the orbital septum is still in place, right? And so you can actually see this stuff herniating against the orbital septum in their distinct fat pads, right? If you took away the septum, you would see what we kind of saw last week in dissection, which was little pieces of corn, right? Kind of whitish, maybe yellowish pieces of corn. Okay, so let me get a different color I'll go dark this time. So medial fat pad, and then you can see it up here as well. They've not broken this into a different section, but this is kind of the central. It has a very distinct demarcation there. This is the central fat pad, temporal branch, right? In fact, the temporal branch has a nice little edge to it out here, because remember, the eye is sitting in here, and we have a bit of space between the margin here and the where it comes together to form the tarsal plates, or to grab onto the tarsal plates. So what ends up happening is you have a nice kind of rectangular shape to this. Likewise, on this side, you get this lashed over by the medial canthal tendon. Okay, you can see up here described lacrimal gland. Well, you know what? There's not much happening there. We're looking at the bony margin of the orbit, the superior lateral margin here. Okay, and so that's again why I kind of emphasized that arc when we were talking about the skull. Likewise, I emphasized this arc down here. Okay, preaponeurotic fat pad is just kind of filling in the transition here from the tarsal plates. Imagine a closed eyelid, right? You have you get two wrinkles eventually. You get the superior tarsal wrinkle where the levator grabs on, and then you get a fold here where the aponeurotic fat pad kind of exists. This is variable. All these are variable in people, right? Sometimes you see them, sometimes you don't. And medial fat pad in here. Okay, simple enough. Cool. Let's look at a few examples and just convince you that this stuff happens in life. Okay, so this is Michael Bloomberg, and looking at this, we can see quite a few things that we've actually already talked about, which is cool. But let's look at the temporal line. We can see a lot of the zygomatic structure here. As this recedes, remember what we're looking at here is not the zygomatic bone going back like this. This is the temporalis, right? Coming up, we have temporal fossa, we have temporalis, and as we'll see, a little bit of fat that wedges up in there as well. Okay, but that's not what we're looking at this for. We're looking at this for the fat pads, right? And in this particular instance, this guy is showing a lot of this lateral fat pad, but very little of the other two, right? We can certainly make out kind of the margin of the tarsal plate, the lower tarsal plate, as distinct from kind of the rest of this kind of transition zone down to the orbital rim. And in fact, the lateral orbital fat is so pronounced that it's actually creating its own bulge in silhouette, in profile, which is quite a bit, to be honest. Okay, let's see. So a lot of people go in to get this corrected, right? You go to, you get a facelift or something. I think they call this lower lid blepharoplasty, which is shaping the lower lid. And often what they do is they'll just cut in there into the orbital septum, and they'll just mine out, just dig out some of that orbital fat and then sew it back together. And so that's what this girl's had, right? So she's gone in and she's got a bit of convexity in kind of that central pad, really, and not so prominent on either of the other sides. And so that was kind of taken out and reduced. I don't think they did a fantastic job, to be honest, because you can still see, at least in the way it's lit, right, you see a pretty strong transition here. But we'll see that this orbital transition is actually another variable that creates this sharper edge, right? That's not all to do with orbital fat bulging, right? As you can see, they've removed it, and you still have a pretty strong transition. Okay, looking at this guy has kind of orbital fat herniating everywhere, right? And this is kind of the balloon animal example. right? You can kind of see, well, you can see quite distinctly, in fact, the medial canthal tendon and the tarsal plates on each side, right? If I just kind of outline this, you can see how all this fits together structurally. Okay, and that leaves kind of the rest of the orbit, which in fact we can actually outline quite reliably, because the difference between bone here and bulging fat below gives us a very distinct outline for this this inner margin. A little bit obscured out here, but then we can trace it down, and we can actually follow it up here. Right, so you have all these edges to the orbit. Okay, and then looking at very distinct separation in the lower fat pads, right? But I want you guys to notice the kind of the continuation, pretty obvious continuation between this nasal fat pad. And the other thing I want you to just remember back to the eye lecture last week was that when you look around, right, this guy's got his glance far from default. It's upwards and to the left, his left. And so, like you saw on those pictures of my eyes, like when you roll your eye that far, it's really squishing this way, right? So he's getting a little bit more of this sticking out, and this one's popping out on both sides, but a little bit of that is relieved there, a little bit of the pressure. So while we're seeing a lot of kind of bulge here, we're not seeing much on the other side. So again, just keep in mind how variable that is as the eye moves around in the orbit. Okay, young Robert De Niro, and you can see here what I'm talking about. Kind of this is more unified central and nasal pad, and then laterally here we kind of see that the temporal branch or the lateral branch. Not much happening up here. And in the absence of any kind of bulging superior orbital fat on the medial side, the nasal side, you get kind of a more or less continuous transition from nasal bone, kind of what ends up being the glabella, the end of the frontal bone, down to the eyelid fold, right? And that's what we're seeing here. But this is only half bone up here, and then down here it's kind of non-herniating fat. Okay, hey, we've seen him again. And let's go forward to this guy, right? This guy is just another example. Again, looking at kind of the transition between tarsal plates and the lower bags. Quite pronounced here, in fact, on this medial nasal branch. Again, appearing very kind of unified. Right, and again, you can kind of appreciate how the canthal tendon grabs right onto the edge of the orbit, right? Remember the gallery abominant last week where the guy didn't attach it. You can see quite clearly that that is the actual structure of the eyes, right? They definitely have to grab onto that inner margin. Okay, and he gets a little upset because I've curated him for the fat section of the lecture. So as opposed to all of his other fantastic kind of features, I've chosen to focus on his fat. So he's a little bit upset about that. But that's all. That's the only reason I put this in. Okay, so looking at Louis Armstrong, right? This is just another example of what I was just saying, that this upper kind of region of the orbit, kind of the superior medial margin, just where it comes into the nose, you have bone and you have fat, right? Those are your two options for all the stuff that's not the tarsal plate in this area, right? So tarsal plate coming down, then on this guy you can see the fat bulging out there, and then because his eyebrows are raised, what we're looking at here is that's just simply the bony orbit, right? And it's good to, you really just have to know exactly what it is you're looking at. That's why we're covering all this anatomy, because this is the kind of thing, if you're referencing something or you're just, you're trying to figure out what goes there just by observation alone, you can easily confuse all these things and treat these incorrectly, or get the edges not to line up, or simple things that you just wouldn't necessarily pay attention to. But if you know that actually, oh yeah, that's bony structure, tendon, fat, it becomes quite a bit clearer. Okay, what happens when you don't have much orbital fat? And this is kind of the converse problem that people have. Like when you get old, you can either get bulgy, baggy eyes, or you can have hollowed out orbits. And this is the less frequent configuration, but it does happen. And essentially, this guy can't go in and get, I imagine they probably can put fat in somehow. I don't know, they might take it out of your bottom or something, I'm not sure, but I'm sure they've tried. But essentially, you get a concave plane in this region up here that we've been talking about. And that, again, is kind of the skeletal orbit. And again, the same thing can happen down here. Instead of having neutral or convex planes that transition from the margin to the kind of lower lid, the tarsal area, you get concave. Right? It's hard to draw concave all the way around, but that's what's happening. And so just know that that comes in a few different configurations depending on how the orbital fat weathers the storm of aging. Okay, last one, last example, and this is just a little bit more of a close-up. And you can kind of see the reason I've given you a close-up is so that you can make a better, appreciate better the distinct transition between tarsal plate and then orbital fat, right? So that's kind of just how it goes. You know, ball, tarsus, and then fat down to the margin, right? Okay, so that is kind of it. We'll get a chance, you'll see it everywhere. Part of your assignment this week is to observe and do a lot of observation, because you'll start to see these things kind of quite clearly now that you know about them. Okay, now let's remain on the eyelid and in the eye area anyways, and talk about the pretarsal fat, right? And this is just fatty eyelids. And this, again, is active research in plastic surgery. They inject lower eyelids and see with dye and see if it diffuses out of this little section or if, in fact, it's an actual compartment. And, in fact, it turns out this little area in front of the orbicularis oculi, right, is kind of subcutaneous fat, right? I mean, it's not deep to a muscle. It's not in its own packet, but it's kind of compartmentalized, right? It has a distinct separation from kind of the rest of the subcutaneous fat, right? And as such, in certain people, it just gets bigger, right? So you get certain people that have fatty eyelid, right? And essentially, it's kind of right below the tarsal plates. You'll get various configurations of a tube of fat running along the lower lid. And this is independent of weight, kind of overall body fat. It's independent of any kind of bulging in the orbital fat. And so kind of essentially you can be thin and have pretarsal fat. It's just kind of a genetic predisposition. Okay, so this guy happens to have a little bit of both, right? So mostly this is orbital fat here, but you can see over on this side a little bit more clearly, a little tube going around. It's not too pronounced, certainly compared to the orbital fat down here, but there is a little bit of fattening in the lower eyelid. Also, this is really good. Let me just erase the ink. A really good example of this whole inferior orbital section being kind of unified fat, right? It's not really showing us any of those distinct fat pads that we talked about. Okay, this is a good example of kind of pretarsal fat on just an average guy, right? Albert Einstein wasn't especially fat, nor was he especially fit, but that we know about anyways. He could have been knocking out one-arm pull-ups when he wasn't doing physics. We don't know. But that's the pretarsal fat on him, right? And it's a very distinct thing, right? If you have it, it's a characteristic that you really need to capture, something that would go into a likeness, right? Hopefully the contrast on your screens are okay, because we're seeing a really, really nice tube of fat in the shadowed area here of a young Clint Eastwood, right? And you can make it out reasonably clear here as well. All right, so you get the little edge of the tarsal plate, and then just as you're kind of getting below the lashes, you still have a nice little section of kind of vertical kind of tarsal plate, but then you get the convexity of the pretarsal fat. Okay, and just one more example, right? Kind of independent of no kind of bulging orbital fat there. Nicely convex, and you can see it here kind of a little bit better. And certainly when he smiles, you can see it. When he smiles, a lot of this kind of cheek area lifts and just accentuates what's happening here, wrinkles it up a little bit more. Okay, so that's pretarsal fat, right? So we have orbital fat, pretarsal fat. And now let's talk about something called SOOF fat, right, which is an acronym that stands for suborbicularis oculi fat, or orbicularis oculi. I should put IS in there. And essentially, this is how it fits together, right? And we're talking about layers, you know, as we start to get into the complexity of these kind of micro features. There's layers of stuff. There's stuff sliding against each other. There's stuff buckling and wrinkling, stuff stretching. It actually is quite complex how it all works mechanically. But in this particular cross section, we know about this. This is the orbital septum right here. So this is the orbital fat. We know about orbicularis oculi. That's this kind of muscle that's been cut through, been kind of sectioned, going above as well. We know about the orbital kind of rim. That's this bit here, right? This is chopped off. That's the sharp edge of the orbital rim coming down. And then what we have is essentially kind of layers of facial muscles down here coming off. We have some of our kind of sneering muscles grab right onto the lower margin, the inferior margin of the orbital rim. We have subcutaneous fat here, but then you'll notice there's just this little sliver between the orbital septum and the bottom of orbicularis oculi, where there's a pocket of fat called the SOOF, suborbicularis oculi fat. And it sits right in there, kind of when you're young. SOOF fat is, you always have it when you're young and you're old. It just kind of has a different configuration, right? When you're young, this is all just sitting up nicely situated underneath the orbicularis oculi, over top of that sharp bony ridge of the orbit, right? That orbital rim is a kind of quite a sharp little line on a person if you don't have the SOOF fat there. But in youth, this masks it over. But in age, you can imagine what happens. In age, some of these ligaments lose their resilience, the elasticity of this superficial fascia that holds the the fat up here in place, the apicularis oculi, all of that starts to sag. And so the big effect visually for us as artists is that this is no longer sitting over top of the orbital rim, but it slides down and makes this little teardrop crescent that kind of runs laterally from kind of the center of the orbital rim out. And so you have a double impact, right? And I'll show you images of this in a second, so don't worry. The double impact is on the surface you get a very hardened transition between lid and orbit to orbital rim and down to the cheek. And then you also potentially get this double wrinkle or this double bulge from the fat bulging up under apicularis oculi. Okay, big explanation. Let me show you this. This is a schematic of where apicularis oculi is compared to medial. This see our little spiral. So canthal tendons. Essentially, apicularis oculi spirals around like this, right? And they've done it a little bit rectangular, this whole diagram. But the SUF bit lives underneath all of it, right? And it kind of it doesn't live underneath this medial part, but as you go laterally out and wrap up, this is where you get SUF just sitting over top of the kind of zygomatic bone, right? So once you're off the orbital rim, you're onto that kind of part of the the zygomatic bone, that kind of eminence, that corner of the sunglasses. Okay, so let's look at this and see what happens, right? So this guy is showing us this little crescent, right? And this is exactly what happens when the SUF fat kind of descends a little bit from underneath, or the apicularis oculi descends a little bit as well, and slides off the orbital rim, which is going to be up here. And so you get this convexity. And it does just look like a little crescent. It feathers out on this side, and on this side comes up over top and actually becomes continuous with this inner kind of infraorbital furrow, right? Because, right, remember this infraorbital furrow is the bony margin of the orbit, but also it's apicularis oculi coming across there as well. And so then the apicularis oculi continues across the orbit and then is outside the orbital rim from there on out. That's why we get that little crescent, which is the difference between where the orbital rim is and where the edge of apicularis oculi. Okay. Let's look at a couple more. Former Prime Minister of Britain, Gordon Brown. A case study in facial fat, in fact, showing us some really well-defined SUF. And literally, this is the configuration that you'll see if the fat becomes visible after it slides off. Occasionally, the fat doesn't appear as a nice kind of tight creased bulge like that. In some instances, it just kind of becomes this big transition onto the cheek, but it leaves a sharp bony ridge where the margin of the orbit is. But this is classic kind of SUF fat problems. Lack of sleep, not enough kind of time lying on your back. I guess gravity takes its toll eventually. Stress, of course, as well. We may see you again, Gordon, for some more fat later. Okay, and this is a subtle one, but she's showing a couple of the configurations, right? You find the infraorbital furrow. Margin of the orbit comes off from there, working laterally, and you can kind of feel a little bit of convexity here. It's not anywhere near as distinct on this edge here as we just saw in Gordon Brown, but you feel a little bit of fullness. But otherwise, the big evidence of kind of SUF fat is the lack of SUF fat on the bony rim of the orbit, right? And that gives you that hard edge. And this goes back to that girl that we were talking about that had the orbital fat removed, but the bony edge was still there, right? Because it didn't put the SUF fat back up. Okay, and last, this is Al Pacino, kind of young and a little bit older. You can see on young Al Pacino, you can see the start of this. And in fact, of course, his orbicularis oculi is still there when he's young. I mean, you can often see this form on babies even, right? This is quite a prominent transition on some people. Okay, and then he gets a little bit older, and you can see that there's less, right now it's, when he's young, it's creating this nice transition across the orbit, right? That's not, well, maybe a little bit more, a little bit rougher on this side, but as he gets old, you can see it's a little bit more exposed, well, quite a bit more exposed. And you can feel it kind of accumulating on this side. Okay, so that's SUF fat. And the last little piece of this eye puzzle of fats is kind of the analog to SUF fat on the top side, and they had to give it a different name, and they've called it roof fat, which is actually stands for orbicular orbicularis oculi fat, right? So I don't orbicularis. I left some letters out there. Anyways, don't count on me to spell it properly for you. Use the acronym instead. I can spell that better. Roof. Okay, so essentially, roof is another piece, is more or less analogous to what the SUF was on the bottom, except it kind of hangs out on essentially where your upper eyelid fold comes down, right? So if your eyelid folds up like this, this roof fat is going to be underneath orbicularis oculi on the top, right? So orbicularis oculi should be continued up like this if this person drew it properly. And then we have the orbital septum, we have the septal fat, kind of the preaponeurotic fat, remember? We talked about that right in the middle of the upper edge of the orbit. So that's the preaponeurotic fat behind the orbital septum, and then we have the roof fat. And roof fat is generally kind of a reasonably neutral thing, right? You only, it contributes to that really kind of beautiful shape on kind of a young, pretty eye, right? If you have, you know, you have this shape of the upper lid, and then you kind of have this crescent out here, eyebrow up here. This crescent is contributed by roof fat, right? And if it's a good amount, but not too much, it's cool. It looks beautiful. If it's too little, you'll see kind of a bonier edge to the orbit, right? You won't see a nice soft transition. If it's too much, that's when you have problems. If it's too much, you get essentially the upper lid, kind of the upper lid of the eye is engulfed by this heavy kind of brow sagging down. And often surgeons will go in and operate on this kind of thing too, an upper lid blepharoplasty, to take some of that stuff out. And then we're kind of seeing two things conflated here. We're seeing also kind of the nasal branch of the orbital fat coming out. And then there's kind of a seamless transition into that big mass of roof fat. Okay, so on this is what I'm just talking about, a blepharoplasty. You can feel, this is not just, oftentimes this problem of the upper lid fold being masked by skin is just caused by laxity in the skin, right, just hanging down. But in this particular instance, there is a bit of fullness to it as well. So you kind of have two things. You have skin that's sagging, but also potentially caused by a bunch of fat sagging down as well, right? So they take the fat out, maybe just cut it there, dig out some fat. This is a little shovel. I'm not sure that they use a shovel, but if you were a little man, you might use a shovel to get in there and dig out the fat. And then they sew up the seam, and you're left with something that's, bears a resemblance to what we were just talking about for a pretty, a well-structured kind of superior lateral margin of the eye. Okay, so that is the upper lid. Essentially, that's the end of the upper lid fat. That's the end of the eye fat puzzle, right? So we've had orbital fat, we've had tarsal fat, pretarsal fat, we've had SOOF fat down here, and then roof fat up here. Okay, so those are all the pieces, and you get a chance to practice hunting for that stuff in this week's assignment. The next section of this lecture is going to move down, and we're going to start to talk about some mid and lower face fats. Okay, see you in part 2.